Hello everyone, this is D. Chinnagokari. I am going to explain about solutions. This is lecture 2. In this lecture 2, I am going to explain the methods of expressing concentration. In previous lecture, I have explained some introduction of solution chapter and also I explained some methods of expressing concentration. So this is in the lecture 2. In lecture 2, I am going to explain methods of concentration. In previous class, I have explained about few methods of expressing concentration like that mass percentage, volume percentage, mass volume percentage. Now in this class, I am going to explain about volume mass percentage. Volume mass percentage. So here what is volume mass percentage? So the volume of solute, the volume of solute present in 100 grams of solution, 100 grams of solution is called volume mass percentage. Volume mass percentage. So here how we write the formula for the volume mass percentage? Volume mass percentage is equal to volume mass percentage is equal to volume of solute by mass of solution into 100. So here what are the units for mass volume mass percentage? ml per gram. Next let us take one illustration here to understand very clearly volume mass percentage. So calculate volume mass percentage of solution of 200 grams of solution of 200 grams of solution which contain 10 ml of HCl. Okay, so now how we can calculate here volume mass percentage? So volume mass percentage formula we already know. Volume mass percentage is equal to volume of solute mass of solution or weight of solution into 100. So volume of solute they given 10 ml and volume of solution, weight of solution they given 200 grams. So into 100. So here we will get that is 5 ml per gram. Okay, 5 ml per gram. So this is calculate the mass of calculate the volume mass percentage of 200 grams of solution which contain 10 ml of solution of HCl. So what is the volume mass percentage? Volume of solute by volume of solution into 100. So weight of solution, it is volume of solute by weight of solution. volume of solute they given 10 ml, that is 10 ml. Mass of solute they given 200 grams. So here when you calculate, that is 5 ml per gram. This is the mass, volume, mass percentage. So simply here 2 zeros get cancelled, 2 ones are 2 5s are. Yes, 5 ml per gram. This is the volume mass percentage. Next we have ppm. This is fifth method, ppm. So here what is the ppm? ppm full form is parts per million. Parts per million. So when we use this type of units, when we have the trace quantities of solute, for example CO2 present in the air, we already know 0.03% of CO2 present in the air. That's why there we use ppm, parts per million. It is convenient method to express that concentration. Even that small trace concentrations also can affect the life. For example, the percentage of CO, it is one of the very poisonous gas in the atmosphere. If the percentage of CO increases up to certain ppm, so it causes for the death of the human beings. So that's why to express that such small concentrations, we use the parts per million. So here ppm formula, weight of solute by weight of solution, into 10 power 6, means in 1 million number of parts present in 1 million parts, that is nothing but parts per million. And we have ppb also. ppb means parts per billion. Parts per billion means 1 part in billion part. So how we can write formula? Weight of solute, weight of solution by weight of solution into 10 to the power of 9, means in 1 billion number of parts present in 1 billion part, that is nothing but ppb. And we have pph also. pph means parts per 100. Parts per 100 means number of parts present in 100 parts, or simply weight of, this is nothing but mass percentage. We can take weight of solute by weight of solution into 10 square, that is pph. It is indirect meaning, that is the weight percentage. So this is about ppm, ppb, pph. So here ppm is the parts per million, ppb is the parts per billion, pph is the parts per 100. So this is about ppm, ppb, pph. When we use this type of methods to express the concentration, when the solute particle is very less, like 1 part in million part, or 1 part in 1 billion part, or 1 part in the 100 parts, like that. When we are having a very small quantity of solute, we use the ppm, ppb and pph. Next we will discuss about one more method, that is molarity. So here what is molarity? Molarity indicated with the capital M. Molarity is nothing but number of moles of solute, present in present in 1 liter of solution. Number of moles of solute present in 1 liter of solution, that is called what? Molarity. Molarity indicated with capital M. Capital M is equal to N by VL. So here number, it is the, here N is the number of moles of solute, and VL is the volume of solution. So if you are not getting understand what is solute, you can watch my previous video. So here M is equal to number of moles formula, weight by gram molecular weight into 1 by VL. If the volume they give volume in the milliliters, ml, so we write same formula like M is equal to weight by gram molecular weight into 1 by, so in the place of you want to write ml, that is 1 ml by 1000, it is nothing but 1 liter. So molarity is equal to weight by gram molecular weight into 1000 by ml. So this is the formula for molarity. So if molarity is 1, if molarity equal to 1, that is called molar solution. Molar solution. If molarity is 0.5, that is semi molar solution. If molarity is 0.1, that is decimolar solution. If molarity is 0.01, that is centimolar solution. If molarity is 0.001, that is millimolar solution. Okay, so this is about molarity. So now let us take one example here to get clarity. So calculate the molarity of solution. Calculate the molarity of solution which contain calcium, which contain 58.5 grams of NaCl in 58.5 grams of NaCl in 500 ml of solution, in 500 ml of solution. So here they given, what is the given? They given the weight of solute, that is 58.5 grams, and what is the given solution? Molecular weight, gram molecular weight of solution, gram molecular weight of solute. So gram molecular weight of solute NaCl they given, that is also 58.5. How it is? NaCl, sodium, only one sodium is there, that is 23 plus 1 chlorine, that is 35.5. So total 58.5. Gram molecular weight of NaCl is 58.5. Now what is the given? Volume of solution. Volume of solution is equal to 500 ml. So this is the given data for us. Then what they asked us to find out? Molarity. What is molarity? Now molarity M is equal to, so they N by VL actually, but they are given weight. So when they give weight, we change it weight by gram molecular weight. The given value in ml, so that's why that is 1000 by Vml. This is the formula we use to calculate the molarity. So here weight is equal to, how much weight they given, 58.5 grams. Here gram molecular weight is also 58.5 grams. So that is 1000 by, what is the volume of solution they given, 500 ml, 500. So 1, 2, so 1 into 2, that is nothing but 2. So what is the molarity of solution? That is 2 molar solution. Next let us discuss about normality of solution. It is one of the another method of expressing concentration. So here what is normality? Normality is nothing but number of gram equivalents, number of gram equivalents present, number of gram equivalents present in the 1 liter of solution, number of gram equivalents present in the 1 liter of solution, that is called what? Normality. So here normality N is equal to number of gram equivalents, number of gram equivalents by volume of solution in liter. So here simply we can write number of gram equivalents of solute. So here N by VL, here N is the number of gram equivalents. How we can find the number of gram equivalents? Here number of gram equivalents by formula weight by gram equivalent weight, weight by gram equivalent weight, that is the formula to find out the number of gram equivalents, number of gram equivalents. And so now substitute this value in this one. So now N is equal to weight by gram equivalent weight into 1 by VL. So here what is gram equivalent weight? Gram equivalent weight is equal to gram molecular weight by N factor, gram molecular weight by N factor. So here N factor is different for different type of substances. I will explain about you N factor again. So here N is equal to weight by gram molecular weight by N factor into 1 by VL, or when you rearrange this equation, N is equal to N factor into N factor into weight by gram molecular weight into 1 by VL. It is just looking like the, up to here it is molarity formula. So we can say simply N is equal to N factor into molarity. So now let us discuss about N factor. So N factor is different for a different type of substances. For example, N factor for acids, N factor for acids is their basicity is their basicity. So here what is basicity of acid? What is basicity of acid? Basicity of acid is nothing but here number of H plus ions produced by acid. We already know acid is nothing but according to Arrhenius theory, which produces the H plus ions. So here number of H plus ions, number of H plus ions produced, number of H plus ions produced by acid is called its basicity. So that is the number is nothing but n factor number. For example, HCl. HCl is hydrochloric acid. So here it is going to produce H plus plus Cl minus, H plus plus Cl minus. So here it is going to produce only one H plus ion. Its basicity 1 and n factor is also 1. N factor equal to 1. Next H2SO4, it produces 2H plus ions and SO4 minus 2. So its basicity, here it is producing 2H plus ions, basicity is 2. N factor also here n factor, I am directly writing n factor, that is 2. Why? Because its basicity is 2. Next acetic acid CH3COOH. So it produces CH3COO minus plus H plus ions. Means even though it is having 4 hydrogens, it is producing only 1 H plus ion. That's why its n factor is, its basicity 1, n factor is also 1. Why? Which means blindly we cannot decide by seeing the number of hydrogens present in the acid, but how we can decide the number of H plus ions produced by the acid. So that is the n factor. Next let us come here, we have 3 acids, that is H3PO2, H3PO3, H3PO4. So here what is the its basicity or what is its n factor? Here simply we can assume that here all they are contain 3 hydrogens, so their basicity is 3, but that is wrong. So here what I said basicity, number of H plus ions produced by an acid. So here H3PO2, this is called hypophosphorus acid. So its structure is like this. So here 2 hydrogens are directly connected to the phosphorus. So these are not replaceable. We cannot they are not going to coming as a H plus ions, but here the hydrogen which is connected to oxygen, it comes as the H plus ion, means it produces P double bond O minus H plus H plus, means it is producing how many H plus ions? Only 1 H plus ion. Hence its n factor is 1. And H3PO3, this is phosphorus acid. So its structure is P double bond OH, H, means here 2 hydrogens are directly connected to the oxygen, so that they are replaceable, and this hydrogen is directly connected to phosphorus, this is not replaceable. So it produces 2 H plus ions, hence its n factor is 2. And H3PO4, phosphoric acid, orthophosphoric acid also sometimes it is called orthophosphoric acid or phosphoric acid. So its structure is P double bond OH and OH. So here 3 hydrogens are replaceable. So its n factor is 3. Even though all these are contain 3 hydrogens, but their n factor is different. Why? Because here n factor is nothing but for acids, number of H plus ions produced by a acid. So here this acid producing only 1 H plus ion, so its n factor is 1. This acid producing sulfuric acid producing 2 H plus ions, its n factor is 2. Here acetic acid, even though it contain 4 hydrogens, but it produces only 1 hydrogen, so its n factor is 1. In H3PO2, how many hydrogens are there? 3 hydrogens, but it produces only 1 H plus ion because of its structure. In this structure, only 1 hydrogen is directly connected to oxygen, that is only replaceable, but these are not replaceable. Why? Because here hydrogen and phosphorus both are having same electronegativity, so that we cannot cleave this bond, means it is not going to cleave, but this bond is going to cleave and it produces H plus ions. And in H3PO3 phosphorus acid, in phosphorus acid 2 hydrogens are connected to oxygen, means it can produce the 2 H plus ions. Here one hydrogen is directly connected to the phosphorus, it is not going to cleave, so its N factor is 2. In H3PO4 3 hydrogens are connected to oxygen and these 3 hydrogens are replaceable, hence their N factor is 3. So this is about N factor of acids. Next let us discuss N factor for bases. So N factor for bases. Here what is N factor for base? So N factor for base is nothing but here, that is number of OH minus ions produced by a base. According to Arrhenius theory, acid base theory, bases produces OH minus ions. So here number of OH minus ions produced by a base is called basicity, acidity of base. So here number of OH minus ions produced by a base is called acidity of base. So here this for bases, acidity of base is equal to acidity of base equal to N factor. For example, let us take NaOH, sodium hydroxide, it is a base, it is going to produce Na plus OH minus ions. So here how many OH minus ions is produced by this sodium hydroxide? Only one OH minus ion is produced. So hence its acidity equal to 1 and N factor equal to 1. Next to calcium hydroxide. So calcium hydroxide produces calcium plus 2 OH minus ions, 2 hydroxide ions. So which means its acidity equal to 2, N factor is also equal to 2. Next to aluminum hydroxide, AlOH taken thrice, so it gives Al plus 3 OH minus ions. So here acidity equal to 3, N factor is also equal to 3. Next to N factor for salts. N factor for salts. N factor for salts, we can find N factor for salts by using the charge magnitude. Salt is formed by the ionic bond, metal and non-metals. So charge of total positive ions, total positive or negative, total positive charge or negative charge of total positive or negative ions is called or is equal to its N factor, So here for example NaCl is there, salt, it is formed as Na plus Cl minus. So here how many positive charges are there? Only one positive charge is there and only one negative charge is there here. So n factor equal to 1. Next CaCl2. CaCl2 comes as Ca plus 2 plus 2Cl minus 1. Here total calcium ions are 1 and how many, what is the charge is there? Plus 2. So n factor is 2, and coming to according to chlorine minus ions, here charge is minus 1, but here we have 2 chlorine ions, hence its total negative charge is minus 2, total positive charge is plus 2. So n factor equal to 2. Likewise we can calculate the n factor, and sometime n factor is equal to n factor is equal to its valency. N factor is equal to its valency. For example, O2. What is the n factor for O2? That is 2. Why? Because oxygen valency is 2. Next N2. What is the valency of nitrogen? That is 3. So nitrogen n factor is 2. Here n factor is 3. Why? Nitrogen valency equal to 3, and sometime n factor is equal to oxidation number. N factor is equal to oxidation number. So that is, for example, M2O3. So this is a metal. So here its oxidation number is plus 3, and M2O5, here its oxidation number is plus 5. Means here equal to change in oxidation number. So here how many electrons are changing? Plus 2. 2 electrons are changing. Hence here n factor is 2. Why? Because here oxidation number is changing from plus 3 to plus 5. That is, by losing of 2 electrons, means change in the number of electrons are also we can take as the n factor. This is about n factor. So now we already know normality is equal to n factor into molarity. So normality is equal to n factor into weight by gram molecular weight into 1 by VL, or that is equal to n factor into weight by gram molecular weight into 1000 by VML. So here also normal solution means normal solution, that is equal to normality 1, and semi normal means 0.5. n is called semi normal. Decinormal means 0.1 n. Centinormal that is equal to 0.01 n. Millinormal that is equal to 0.001 n. Normality is called what? Millinormal solution. Next let us take one example here to calculate the normality of a solution. So now let us calculate the normality here. Calculate the normality of 200 ml of solution. Calculate the normality of 200 ml of solution which contain 98 grams of H2SO4 sulfuric acid. So here normality formula, normality is equal to n factor into weight by gram molecular weight into volume they given in ml, that's why 1000 by V ml. So here we already know normality n factor for sulfuric acid, that is 2, weight they given 98, and gram molecular weight of sulfuric acid, here 4 oxygens are there 64, here 1 sulfur 32 plus 2, total it is 98. Gram molecular weight is also 98. So 1000 by what is the volume they given 200. So that is 2 ones 2 5, that is 98 90 will get cancelled, 2 5 is a 10. So that is the 10 normal solution. Yes. This is about normality and molarity. In the next classes I will explain remaining methods of expressing concentration. So if you have any queries, you can comment on this video, or if you like this video, just press a like button.